Can I request everybody to please outside, please come inside. We are just beginning. Is outside people already? Have you started?
Dear friends, let's get inside. We are going to start the event. I request everybody to get inside, please.
Okay, we are just starting. Let me invite Kiran. Kiran is the MC of the today event, and Kiran will take along the entire day with you all. He will share, he will update, he will give all the details to you. So, thank you, Kiran. Please welcome and start the show.
Right, thank you, sir. A very good morning to all the people present out here, and I welcome you on behalf of ISHRAE's Mumbai chapter for Symposia 2018. Guys, let's cheer for all of you people present out here with a big round of applause, guys. Come on. So before we begin with this program, I would request everybody to please kindly stand at your own place for the national anthem, and after that, lighting of the lamp. Thank you. Now I'd like to call upon our chief guest, Mr. Murari Sinhal, Group Senior Vice President, and Mr. Prakash Loia, Senior Vice President, Power and Utility from Reliance Industries Limited, along with Mr. Sanjay Jadhav, Mr. Subramaniam, the National President of ISHRAE, and Mr. Benkard from Schneider Electric to please kindly come forward and light the lamp. I would request everybody to please give a big round of applause for all these dignitaries present out here. But I would request all the chief guests who are present here for the lighting of the lamp to request you to please stand for a while for a group photo. May I now invite Ms. Sangeeta Jangiani, President, ISHRAE Mumbai Chapter, to please kindly come on the dais and give the Mumbai address.
Good morning. A very warm welcome to the 7th edition of Symposia. I welcome Honorable Chief Guest Mr. Sinhal, Mr. Loia, distinguished speakers, office bearers, and ladies and gentlemen. Welcome to the world of ISHRAE. Dissemination of knowledge is our key objective. As I stand here, this event is being streamed live across the globe. ISHRAE in your pocket. The ISHRAE app on your smartphone brings you a host of technical literature. Learn at your pace, anywhere, anytime. It is said, sharing knowledge is gaining knowledge. ISHRAE Institute of Excellence has crafted a series of certification courses, and we at Mumbai are pleased to announce certificate courses in clean room, design, service, and these courses will start September 2018 onwards. Make in India is a phrase we are all familiar with, but this needs to be complemented with research in India. So we at ISHRAE have a research promotion wing for the advancement in the field of arts and sciences of air. We solicit your help in making this a success by way of making a small donation. Even a small amount would be of immense help. ISHRAE is pleased to bring to you Searcho, a B2B digital marking platform. Both paid and free listing options are available. ISHRAE has a vibrant youth and women wing, and we believe that the best way to connect is through fun and games. So, the youth at ISHRAE presents to you ISHRAE Cricket League, which is nothing but an intercity cricket tournament exclusively for ISHRAEites. Do stay connected. We have lots more up our sleeves coming your way. Enjoy the day, and thank you.
Thank you so much, Sangeeta ma'am. Now I would like to call upon our chief guest, Mr. Mauricio Sinhal, Group Senior Vice President, on stage. And before I call him, I would like to introduce you. Mr. Mauricio Sinhal from Reliance Industries Limited. He is presently Senior Group Vice President, Utility Services. After completing the graduation, Mr. Sinhal joined JK Synthetics Kota. After working for 10 years in JK Synthetics, Mr. Sinhal joined Reliance Industries Limited in November 1981 and continued his long-lasting service journey in Reliance Industries till date. Mr. Sinhal was founding member of Reliance's first polyester plant at Patalganga in Raigad, Maharashtra. After Patalganga plant establishment, Mr. Sinhal has worked for all manufacturing sites of Reliance Industries, petrochemical complex at Hazira, and oil refinery at Jamnagar, Gujarat. He has wide experience in design and installing of 4 lakh TR of refrigeration and air conditioning, industrial boiler, water treatment, STP, nitrogen plant, compressed air system, and all of the utility services used in industry. Mr. Sinhal was instrumental in establishing Reliance Infocom Telenetwork in the year 2002. Mr. Sinhal was head of engineering of Antilia and HN Hospital project. Presently, Mr. Sinhal, at age of 71, working restlessly for digital dream of Mr. Mukesh Ambani, Reliance Jio. I would request to please give a big round of applause for the gentleman while he comes on stage. We welcome you, sir.
Good morning. The President, ISHRAE Bombay Chapter, Mrs. Sangeeta Jangiani, Shri Rajesh Bala, the Managing Director of Stools Company, distinguished guests, and my friends. Thank you very much for giving me this opportunity to talk to you at Symbiosis 2018 of Data Center. First of all, I would like to congratulate ISHRAE and ASHRAE Bombay Chapter for taking this initiative to organize this national program on data center and convergence of all stakeholders in this field, in this hall. This is actually the need of hour of India. I thank sponsorer for the same. It is my pleasure to be here to show my thoughts about the data center in India. Data center in India are growing exponentially as per market research data available. That computing revenue in India is expected to reach about 7,000 crores annually. And the growth on the same is going to be 25% annually. At Reliance, we operate our own data center located at Jamnagar, New Bombay, and Nagpur, having huge area and lot of power consumption on the same. I request all stakeholders of the data center to give importance to the PUE. PUE means, as all of you know, that effective power utilization or the efficiency of the data center. The major contributor are to maintain the PUE. In my opinion, the major contributor are the server rack designer and the designer of air cooling system for the servers. As on date, data centers operating in India are operating in the range of PUE in the range of 1.723. In my opinion, which can be definitely, as per our experience operating data centers in Reliance, this range can be brought down to 1.4 to 3 as PUE based on the Indian climatic conditions. A data center invariably need a house many number of racks manufactured by different server manufacturers. But they have their own design of cooling. Each rack manufacturer have their own design of heat sink and air movement within rack for removal of heat. Somebody follows that cold air is supplied from the top and hot air is collected from the side. Some people follow that cold air is supplied at the bottom of the rake, bottom side of the rake, and hot air is collected at the top. Like that, there are different configuration preferred or designed by different manufacturers of server rake. As per our own operating experience, in Reliance, we have concluded that most efficient way is to supply the cold air at the side bottom and collect the hot air from the top. And with that type of system operation, we have achieved the PUE as low as 1.4. So I have a small request and suggestion for all server manufacturers that to achieve the best PUE, the server rake designer should design the cooling system of the server rake in such a way that we get best possible efficiency, that is PUE, and it is possible, definitely as per our experience, that it is possible to achieve definitely PUE somewhere in the range of 1.3 to 1.4 instead of that present operation. Most of the data center are about 2, which is definitely the waste of power, and we should, as refrigeration engineers sitting here all from different field, should concentrate on this issue, and all server manufacturers should join hand together to find the best way of design and operation of data center cooling. Thank you.
Thank you so much, sir, for your views. Now I request Mr. Vikram Murthy, ISHRAE National President-elect, to please kindly felicitate Mr. Murari Sinha. Come on, give a big round of applause for Mr. Vikram and Mr. Murari.
As I said to you in the morning, that this day has a lot of surprises, and I'm very pleased to say that the entire event Symposia 2018 is live webcast on ISHRAE TV through YouTube. So you can inform all your friends all over the India or world, wherever they are. If they want to witness it, they can witness it live. It's total, the complete event throughout the day is live.
All right, now may I call upon the next chief guest, Mr. Prakash C. Loia, Senior Vice President, Power and Utility, Reliance Industries Limited. Before I call him, I would like to introduce and give a few words. Mr. Prakash Chandra Loia is a mechanical engineering graduate from Birla Institute of Technology and Science, Pilani. He has 43 years of experience and currently working as Senior Vice President, Power and Utility in Reliance Industries Limited. He has handled various projects for refinery, petrochemical, synthetic filament, internet data center, telecommunication and infrastructure projects. He is instrumental in getting Hall of Fame 2018 for RCP Building 22, Platinum Certification for Reliance Corporate Park, Emerson CUP 2015 Excellence Award, National Energy Conservation Award for DAKC. He has given presentation on energy management, saving and benchmarking in BTS at Rome in Intellect 2007. He has also given presentation in ACREX 2004 and 2007. I welcome you, sir, and I request you to please kindly come on dais and say a few words.
Good morning, everybody. I welcome all the delegates, presenters, organizers, and sponsors of Symposia 2018. I wanted to take this subject in a different philosophical way. Now there is a urgent need of mankind to have a quality of life, improvement of their life. It leads to the development, continuous development and improvement. Now you have seen the introduction of smartphone, which helps in faster communication, entertainment, informations, and daily transactions for our daily needs. Now in the morning, you see that everybody is looking his phone, WhatsApp, all these things. All this has improved the quality of life. Now, we have seen the WhatsApp, Paytm, and all faster communications, gateways and all these things to transact our daily needs. All these needs a large amount of data storage, transportations, analysis, and which leads to the growth of the data center. Now, for improvement of the quality of life, data center is the need of today. And at the same time, when the data center is growing, there is a large power requirement and all these things are there, which is creating stress on our natural resources. This leads, so we both all are coming together to meet both the ends, to improve the quality of life, and at the same time we should not load our mother earth. So what I request all of you to build, design and operate the data center in most energy efficient way and use the natural resources. That is the need of the today, and I think we come here to collectively work together to achieve these goals. Thank you.
Thank you so much, Mr. Loia, sir. Now I request Mr. Pankaj Sareen, National Chair Program, ISHRAE, to please kindly come on dais and felicitate Mr. Loia, sir. Thank you so much. May I now invite Mr. Benkard from Schneider Electric to please kindly come on the dais and say a few words. Mr. Benkard from Schneider Electric.
It's an honor to be here, basically because I consider myself as a kid in the HVAC industry. I was born in 1989 in Voltas and pursued various career ambitions of mine. But it's an honor and privilege to be in front of all of you. These 28 years have taught me, I might be doing various jobs, but by heart I'm a cooling engineer. And somebody fondly recollected that the first Acrex 1997, I was working like a ant in the whole progress, and it brought me a lot of old memories, and really thanking you for remembering that. So this is the industry I belong, and when Sangeeta requested saying that we are doing this data center symposium, so Schneider Electric and data center goes so well hand in hand. And it's all about energy efficiency, and like the chief guest mentioned, it's like energy everywhere for everyone at every time. That's the basic fundamental. Energy is the fundamental right for every human being on earth. And if we have to have that continuous, I don't need to stress the fact that resources like electrical energy, water is becoming scarce, and every drop of it and every ounce of it we save, it's better. And just to give you some data points, like Mr. Sinhal mentioned, that you know, I don't need to be quoted here, but just hearsay information, if there was 150 megawatts of IT load deployed over the last, say, 15 years, what I'm told is that 400 megawatts is going to be deployed in the next 3 years. And that's exactly what Mr. Sinhal was mentioning. And Mr. Loia was mentioning that the smartphone, you know, we just cannot take our eyes off the smartphone, which means it's all about data. It's all about the digitization, urbanization, and industrialization, which is all about data monitoring. Every one of us maybe are wearing a, you know, smart kit here, which is managing our heartbeat, pulse, as well as how many steps we are walking per day. We never used to do this in the past, which means there's going to be too much of data, which means there's going to be a huge proliferation of data and data management. And for that, we saw the PUE numbers scary, 1.7 to 3, which means you're spending unproductive energy to actually manage this data. And we as HVAC engineers, if we can bring that about, you know, for the society, for the planet, that's what our objective should be. In line with this, we have our colleague Sanjit Sandhu coming in from Singapore, who to talk about how you know, we think the data center evolution is going to take place, and what are those energy efficiency methods which we can adopt. Thank you very much for this honor. Thank you very much.
Thank you so much, Benkard sir, for your valuable opinion about the same. Now I request the first speaker for this wonderful event, Mr. Sanjit S. Sandhu. Before I begin, I would request everybody to please listen to the profile. We have got a Sanjit, a specialist vice president. Sanjit joined APC by Schneider Electric in December 2008 and is currently vice president of the Data Center Regional Application Center International, covering the international perimeter of Pacific, East Asia, Japan, India, MEA and SAM. Sanjit heads a team that supports the delivery of the full life cycle of data center solutions, from the pre-sales, tender and execution for the whole portfolio of Schneider Electric's products, and services to ensure Schneider builds a strong capability and expertise in data center solutions. Core to the function is providing the competency in being the subject matter expert for DC design, consulting, design optimization, pre-sales, DC assessments, tendering, project management, execution, critical facility. And the first topic for this wonderful event is your data center ready for the next big idea in cloud and at the edge? I would request Mr. Sanjit to please kindly come on the dais. Please request you to give a big round of applause for Mr. Sanjit.
I guess it's a privilege for me to start off the presentations today. Before I start, I'd like to also thank ASHRAE Mumbai chapter, I'm Singapore chapter, for the great contributions of ASHRAE to engineering, to HVAC, and also to society. My name is Sanjay, and today I'll be talking to you about, is your data center ready for the next big idea in cloud and at the edge? So today, we see that businesses are highly dependent on data centers. We see a lot of new ideas being brought out in terms of new business avenues, new revenue streams, the ability of new ideas using data center and IoT to improve business efficiencies and optimizing resources. Just a show of hands today. How many of you have taken a flight over the last 4 days or flown into Mumbai for this conference? Okay, it's quite a few of you. Let's look at the digital touch points of your experience. You must have booked a flight using a mobile app or the internet, preferably through a loyalty program. You would have checked in at the airport using your mobile phone. You would have looked at updates in your flight status through your mobile phone. It could be also a change of gate that occurs prior to the flight itself. And on the plane, you probably leverage Wi-Fi, possibly gone to social media to talk about your experience. So the airline industry is very much connected to IT, to the Internet of Things, leveraging digitization, and of course the data center is very, very critical for delivering their product. And there are many more examples of this. So today, if you look at the global data center IP traffic, it's 15.3 zettabytes annually, and 15.3 zettabytes, a zettabyte is 21 zeros. Okay? And the global IP data traffic will increase threefold by 2020. If you look at the Internet of Things, there are 5 million new things being connected every day. And this would be up to 50 billion connections in 2020. So that's vast amount of data. So today we've seen also the coming of the data loss. And what has been the subset or the evolution of the data loss? It's caused many builds of data centers, hyperscales, especially in Europe and in Asia. The data laws have just been enacted, and today the data laws are in progress in the EU. This started 25th of May this year. If you look at edge computing, 40% of what's created in data today is processed, analyzed, and acted upon at the edge. So let's ask ourselves, what is edge computing? With the ideas of new data, the ideas of big data, the Internet of Things, new businesses, the coming of the data laws, we've seen the build of hyperscale data centers in Europe and in Asia. Okay, many data centers are being built for geographical coverage, and this started about 6-7 years ago, and it's progressed to a big amount of builds recently. And we look at the builds for web giants and co-locations. The web giants today are also building or taking up space in co-location. If you look at Europe, 40% of the web giants are taking up space in co-location. In Asia, 80% of the web giants are taking up space in co-location. In India, from what I see, it's almost 90%. And also with the co-location and with the data loss, digitization, what's occurring today is one of latency, right? With the new businesses that's occurring, data that is being crunched, we're seeing latency issues occurring. We're seeing new businesses, we're seeing the smart factories, we're seeing the smart grids, we're seeing the smart cities, all of this with enormous amounts of data being produced. And because of that, we have to bring the computing power closer to the edge of the network, closer to where the users are, closer to where the devices produce the data. To solve these latency issues is the emergence of edge computing. So edge computing has many technologies that we need to be aware of. It's highly distributed, and it occurs in many forms. It occurs as a rack with associated UPS power, associated cooling. It occurs as standalone, in office premises, on the shop floor, at the factory. It occurs as small, medium, and large builds that could occur within the edge of the network. And we see also co-locations that actually build, if they want to be strategically placed The builds are usually not at the 20 megawatt size, though the infrastructure is. The locations is important. The builds at 2 to 3 megawatts per phase usually. And we have prefabricated data centers that offers speed to delivery to facilitate the edge computing that's required in the industry today. So, enterprise, co-location, and web giants are increasingly looking at strategic locations to place their data centers. So, we have the edge with the massive information from local things, providing significant local computational power, and also to store and deliver high bandwidth content to users, especially even today with video streaming that's occurring. So with the distributed IT with many distributed data center sites, this creates its own complexity in the ecosystem of the edge and the cloud. The expectation from business owners is IT performance, higher expectation in terms of availability and security and speed at the edge. Management systems are expected to react fast to identify faults within the data center and to come up with a root cause so that the future cause does not occur again. So the issue that we face today with multiple sites, distributed sites, is the lack of actionable information. So the next big idea is also part of what we see in the business, in IoT and digitization. Today it's one for the data center to provide the visibility that is actually required. A visibility to provide better reliability, efficiency, and for the edge to work as what it should. So within the edge itself, right, we believe that a IoT open operable system in the cloud is required so that we can gain the insights into the data center, especially when it is multiple sites and it's very much distributed today. Right? The ability to collect, to remote monitor and analyze, to have a system where we get external experts to understand from the data what's going on and to infer from that. Scale management of the systems to make it not limitless, but to an extent where it can be increased exponentially as the business requires. And to have, of course, what we talked about, prediction that will come over time, and I'll talk a little bit about that later. So we believe in our solution today, which is cloud-based, which is open, is the EcoStruxure IT or EcoStruxure for data centers. So if we look at the bottom of the slide, we have the first layer as the connected products. So in first instance is to have the medium voltage, the low voltage, the UPS systems, the cooling systems, all being able to be connected. That's the first instance. And then we have the middle layer, which is edge control. Edge control is what we have in our data centers in terms of building management systems, in terms of data center infrastructure management. But what is key in terms of having the data going into the cloud is the apps and analytics and the services that will be derived from the multiple sites, pushing data into the cloud, having a pool of experts that can infer from the data to improve the efficiency, to use artificial intelligence and as artificial intelligence matures over time to understand the behavior of the equipment and to center itself. Now, this moves us closer to condition-based maintenance, proactive maintenance, hyper-convergence of the data center and the software-defined data center. So as I said, it's important that we get all of these sites connected, collect and analyze, have a series of experts to understand what these data mean, to be able to scale the data center because sites are increasingly being added into the cloud, and to ensure that as data is analyzed, we improve efficiency and improve performance of the data center itself. Now, what will be the impact of edge computing? So edge computing itself is a subset of the whole ecosystem, with edge and the centralized cloud data centers, or the larger computational power that comes from the bigger data centers into the edge, into multiple sites. And if that's not handled properly, there are many outages that would occur, and this is now seen over the last couple of years. So key is to understand the performance of a data center when it becomes a subset of the ecosystem. So in this slide here, what's in red is the centralized cloud data center. And we base this on uptime topology based on a tier 3 topology. There's more so on a 2N. We get 1.6 hours outage per year. Now over to the left, to the blue, or to your right, you see a centralized cloud, and now with the edge data center connected to it. And as I said, the data centers are multiple in nature, right? And it's distributed in nature. So with the edge data center, sometimes we have it on a shop floor. So for this example, let's say it's a tier 1 topology for the data center. Coupled to the tier 3 data center, the downtime is 31 hours a year. So it's important for us to understand how the ecosystem of edge computing affects reliability as we move forward. Important would be to be associated with partners who understand the significance of the hybrid data center, the multi-location data centers, right, and the effects that it has on the business, and how critical the business is in terms of having the correct design for that. A partner who understands the various standards in the industry. So we've got the Uptime Institute with the tier 1, 2, 3, and 4 topology that offers various different reliability. Also, ASHRAE has contributed a lot in terms of the thermal guidelines for data processing environments that has now increased the air on rack, that has enabled us to reap the benefits of free cooling and evaporative cooling. So let's have a look at some of the topologies that we have in the data center field. What is very common in terms of reliability is the Tier 3 Uptime Institute certified data center. So this data center offers concurrent maintainability. That is to say that any component within the data center can be serviced without interrupting the load to the IT equipment. So this is just to depict what it actually looks like. We have on the right side of the screen a normal supply, and on the left side of the screen is an uninterruptible power supply. Okay, so you have one on UPS and another feed on normal supply. They're tied in by a bus, so the IT rack sees two UPS supply. The UPS run at almost 100%. In a concurrent maintainable facility and in uptime topology, the primary power source is the on-site generation. And that could be generators, it could be fuel cells, it could be renewable solutions. But key is that the on-site power generation has to be within the property of the data center for security reasons. A tier 3 data center in terms of continuous cooling is not required by the tier standard, but operationally, depending on the heat generation of the rack or kilowatt per rack, the continuous cooling is going to be required. Then we have the Rolls-Royce of data centers, the fault tolerant site that is tier 4. In a tier 4, any fault that occurs within the topology or the M&E infrastructure would seamlessly transfer to a subsystem. So the tier 4 site is fault tolerant. It can take a first degree of failure. It has multiple UPS distribution. It's on a 2N topology. Each of the UPS system work at about 50%. Operationally, they go about 35 to 40% usually. Continuous cooling is required. Compartmentation is required. Then if we look at the data centers itself, we have a combination of regional data centers, combination of large co-locations that is being built. It's being strategically placed geographically closer to the network edge because of the edge requirement and to resolve the latency issues. Much of the builds today, to save on capex and to understand the market and the business trend, is to be modular and just to build as you use in terms of the medium voltage, the electrical distribution, the on-site generation, right, and the cooling system. So you build as we see the business, and this is to facilitate. Okay, this to ensure that we facilitate the business itself in terms of the capex and expenditure and the market trend. I've lost my. Sorry about that. It's a problem of digitization here. Say again? To guess. But it's not going to the next one. So I think I'll just do a quick recap. So we're seeing many builds occurring, right, in large data centers or medium co-location in terms of size. The builds are occurring in a modular fashion. So we build as we use as the business comes. The sites are strategically located to ensure that we alleviate the problems with latency, and we build as we use. So with the core topologies for reliability, then comes the various strategies in terms of controlling capex costs and also improving efficiency in terms of the topology. What you see here is a block redundant topology, and in this topology, instead of providing 200% UPS load for the IT, as I said earlier, in a tier 3 usually, or even a tier 4, it's a 2N topology, right? So you're providing 200% of UPS capacity for the IT load. Now we look at the various different strategies in a block redundant. Now we can reduce capex because we're providing 130, 140% in general UPS capacity for the IT load. But we also must note, this is not a solution for all geographies or all countries or all instances. It's a case by case, depending on the requirements. Also, in some cases, it will require highly skilled personnel to manage the site also. So next is just looking at the a block redundant topology on the generators. So we can also offer to reduce the number of equipment in terms, in this case, is the generators, and offer a block redundant topology to provide the 2N topology. Next, as I said, core is the Uptime Institute tiering, and then there are subsets of that. This is a tri-redundant topology, and in this topology is still two power feeds to the rack or to the IT load. The UPS capacity is 150% of the IT load. So now you just reduced the capex on the UPS spend. Now in the tri-redundant topology, it also depends on the situation that you're in terms of the requirements of a project and also a country. In some instances and in some countries, you have certain capacities of transformers or UPSs or the product line that is cheaper for a certain size, and that's one of the ideas in terms of using a tri-redundant topology to reduce the capex. Okay, but it still offers the resilience of a 2N topology. So, with the ASHRAE thermal guidelines, we're able now to increase the on-rack temperatures for the chilled water systems or the cooling systems. We are able now to increase the chilled water temperature itself also. And one of the issues that we see with higher densities in racks is the problems of cooling in the data center. It's more or less settled for the electrical distribution. More thought today is given to the cooling systems because it also offers a lot of efficiency that can come out of that. So what we see here is a data center that's lost its cooling due to a grid failure, right? And it's important that we have the proper controls in place to mitigate the rise of temperature in the data center. So this is a typical scenario. We lose the grid, the generators or the on-site generators comes on, the cooling system is shut down. If it's a 5 kilowatt rack, in 4 minutes, you've lost the rack, right? So the pumps start on, all the chillers come on at the same time. You've got to ramp up the reduction in temperature, ramp up the chillers, and then reduce the temperature within the data center as soon as possible. And one of the strategies is using a thermal buffer system. It's like a UPS for a cooling infrastructure. So these are just some of the various strategies, and also with the increase in the thermal guidelines in the data center, as we increase the temperatures, there are also issues or strategies that needs to be in place for humidity control. So with that, we've got the centralized cloud data centers, the co-locations that is being built, and with digitization, with IoT, with all of the new business ideas that's coming up, with smart factories, with smart cities, we're seeing latency issues that's being built. We've got the various technologies to deal with the multi-distributed sites in terms of the technologies to provide for the edge computing or the solutions for that. So today we see the issue is one of visibility, and we believe that a cloud-based system is necessary to connect all of these multiple distributed sites to perform and to understand in terms of the data, to have the data in place and experts to look at it so that we can start to understand the prediction and do the analytics for prediction of equipment failure. And also, with all of this data together, to work closer towards the management of data centers as a service. So with that, I thank you. Thanks.
Thank you so much, Mr. Sandhu. Now I request Mr. Shankar Sapaliga, RD West, to please kindly come on the dais and felicitate Mr. Sandhu. Mr. Shankar Sapaliga. May I now request Mr. Subramaniam, National President, ASHRAE, to please kindly come on the dais and say a few words.
A very good morning to all of you. You may be wondering what ISHRAE is, why we are into talking about organizing a program on data center and why I am here. The purpose for which I am here is to welcome all of you to this first national program which ISHRAE is conducting, and this is the first national program that is getting rolled out for the whole year. ISHRAE is doing a lot of national programs, chapter level programs, regional level programs, and even technical programs outside the country as well. Now, just to brief you quickly on what ISHRAE is all about, and before that, I would like to thank and welcome our chief guests, Mr. Murari and Mr. Prakash Loia from one of the most powerful business houses in India, Reliance. Thank you, sir, for coming and supporting us in this program. And we are also very honored that we were associated with you for the ISHRAE Hall of Fame, which we had all of you there with us in Bangalore. Now, ISHRAE is a society with a lot of individual members. Our membership strength is going beyond 25,000. We've got professional members, student members. And the theme which we have taken for the year is STAR, which is, STAR stands for Sustained Technical Excellence, Advocacy and Research. Now, what we do in ISHRAE is a lot of technical work. And in the technical work that we carry out, it reaches out our members, it reaches out the industry in terms of technical seminars, national level conferences, technical programs, workshops, dedicated workshops, which is helpful for the design engineers, project engineers, service engineers for the built environment, be it data center, be it healthcare, commercial buildings and various industry segments. And what we do in this process is also the advocacy which we do. So we do a lot of advocacy with government, with academia and the industry as such together. And these research activities again that we carry out, that is one of the activities which we have strongly taken up in the last couple of years. And the research activity is industry led and academia supported, and wherever required, we have got the support from the government as well. Now, when I mentioned to you about the government, the Department of Science and Technology, we are doing some projects. We have already submitted the proposals to them, and they very much want the industry to come forward and provide solutions to the various problems that the entire government and the industry and the nation is facing. And there is a lot of support from the government, and we are collectively getting the support from the industry, from the individual members and the academia, and doing a lot of projects there. And one of our other important wings is ISHRAE Institute of Excellence, where we are focusing specifically on education and certification. Now, as you know, you would have seen in the first presentations and the special chief guests now who addressed us in the beginning, the need for technical expertise, whether you address energy efficiency, whether you address the design or the operation and commissioning of the data centers or the built environment, there is a lot of requirement of quality manpower and technical excellence in these subjects. Now, how do we get there? The only way in which we can get there is a constant education and certification of the personnel who are handling all this, be it certification, be it design, be it installation, be it commissioning, be it operation. At each of these levels, we have to ensure that the entire manpower who are doing all this get properly trained as per the codes of practice. And how exactly? Because the owner, the stakeholders look for this quality in every part of their business operation. So ISHRAE has taken this as one of the primary responsibilities to ensure that we come out with certified professionals, which is termed as ISHRAE certified professionals. In fact, we have done that in the ISHRAE certified professional in air conditioning design, in air conditioning service, in clean rooms, and these are names of the individuals who are certified. They are there on our website, and we are also going to roll out more and more of these certified professionals, ISHRAE ICP programs covering various disciplines. In fact, there is a team which is working on ICP, which we call as ISHRAE certified professional for healthcare, and going forward, we also will be looking into data center design and BMS, building automation system, and so many other requirements as well. And ISHRAE, we conduct national level and international level programs and exhibitions, and one of the flagship programs which is there for us is the ASHRAE 2019, which is being held in Mumbai. So we request you to mark your calendar, to block your dates for the February 28th to March 2nd. You will be definitely seeing a video of this subsequently today. Please come over and then see the industry which is there to present to all our members and the industry as well, to what is there for them, the current technologies, the services and things. And one more exhibition which we have also taken up, which is an offshoot of ASHRAE, is RefCold, refrigeration and cold chain, because that is a special industry which requires, which is having a lot of government attention, which is a day-to-day requirement of all of us. We need fruits, we need vegetables, we need them to get delivered to us at the proper temperature and proper, quality. To do that, there is a lot of focus on refrigeration cold chain which is required, and we have now launched the refrigeration and cold chain exhibition which is called RefCold. And today's program is very much the need of the hour, the data center. It is said that, in our human body, if you pull out all the nerves, I think possibly it runs to 12,000 miles or something like that. Now, I have seen some couple of data centers. If you pull out all the chill water pipes and cables and all that in tier 3 or tier 4 or tier 2 data center, possibly I don't know how many kilometers and miles it's going to run. Obviously, there is a lot of challenge in the designing, in the operation, in construction, in execution, commissioning of data centers. There are a lot of issues, a lot of challenges which ought to be addressed, as mentioned earlier by the speakers and the chief guests. Now, to understand this, definitely ISHRAE Mumbai chapter has put together an expert panel of speakers, distinguished speakers from across the country, and truly this is a national program because what the speakers are presenting here is being video cast across India, and all our ISHRAE members sitting at 42 chapters are in a position to watch all this, which means this is got such a benefit. And the data center, a lot of things are there with respect to temperatures, built environment conditions. It's not that do we do 23 degrees, do we do 50% RH. So a lot of changes have happened. Now, to get to know all of this, I think ISHRAE Mumbai chapter has put together a lot of distinguished panels of speakers. So these are very good initiatives which are taken by our chapters across India. So our best wishes to the ISHRAE Mumbai chapter, and it's very nice that we see the hall packed here to hear to the speakers of data center. So thank you very much, and for more information on ISHRAE I request all of you to log on to ISHRAE.in, www.ISHRAE.in, and see the amount of information which is there for everyone with respect to technical content as well as education and certification programs. Thank you.
Thank you so much, Mr. Subramaniam. Now I request Mr. Mihir Sanghavi to please kindly felicitate Mr. C. Subramaniam.
Good morning. Good morning, friends. Good morning. Friends, let's give this gentleman a big round of applause for heading an organization which has got 22,000 members across India with 42 chapters. In last 3 months, I am aware he's traveling average 20 to 25 days a month, whether it is national or international. Such kind of dedication is unparalleled, and it is our privilege and honor of ISHRAE Mumbai chapter to have you here, sir, and I mean give us a word of advice. Thank you so much, Mr. Subramaniam. Thank you.
Thank you, Mr. Subramaniam. Thank you, Mr. Sanghavi. Now it's time to listen to the next speaker for this wonderful morning. And I would request to please welcome Mr. Mauricio, Director, Data Center Cooling Product Management, IT Division, Schneider Electric. Before I begin, I would like to say a few words. He is working in the cooling business for more than 15 years, specializing in mission-critical applications and IT data center solution. After attaining a master's degree in electronics engineering at the University of Padua, he cooperated with the Italian Siena Research Institute and the Euratom European Institution for Nuclear Energy, focusing on nuclear fusion applications and control. In 2003, entered the cooling business, starting his experience at Uniflare SPA, leading manufacturing company of cooling units for mission-critical applications. Within Uniflare, he worked in R&D and product management roles, developing his expertise in thermodynamic solutions for continuous cooling, high temperature operations and noise impacts. Since 2011, he works at Schneider Electric, Global Specialist for Energy Management, as Product Line Manager for Technical Chiller, and on October 2015 took the strategic lead for Air Handlers 2. Starting from May 2018, he is the Director of Data Center Cooling Product Management, leading the team involved in both strategic and tactical management of the cooling product portfolio for data center. May I request everybody to please give a big round of applause for Mauricio Frizzy.
Thank you to everybody to be here today. It's an honor for me to be and to talk with you guys, to work with the ISHRAE on the design for the next generation of data center. I think that data center right now are the second source, the second energy eater in the world, just right after the traffic air traffic control. So definitely working on the data center and working on the data center energy optimization, it means work to improve the planet, to reduce the overall global warming and to reduce the global energy footprint. It's funny to know that a lot of times people that try to fight against the energy consumption, that try to promote energy-saving solution and says that the technology is eating the energy, they are doing this using technology. So every time that people write to, on Facebook or on the social media, their campaign against the carbon footprint, they are, in this moment, in that moment, increasing the carbon footprint. Nobody realizes, not a lot of people realize this, but it is true. It's true that the data center is part of our life. We depend on data center. Our life depends on data center. And the data center are impacting a lot on the overall energy consumption in the world. And looking at cooling, cooling in a data center is definitely the most important, the most relevant part of the energy consumption. There are a lot of discussion about how much cooling works on that. Not less than 40%. Between 40 and 50% on the overall energy consumption of the ancillaries of the data center is based on the cooling. So working in order to decrease the energy consumption of the data center, it is mandatory to decrease the energy consumption of the cooling. The more we are able to work on the cooling portion, the more we are able to reduce the total energy consumption of the data center. I'm in the business of data centers since 15 years, and probably as all of you, we recognize how the technology is changing, how the challenges are changing in the last 10 years, in the last 5 years, in the last 3 years. The technology is moving, new solutions are coming, but the data centers are changing. The data centers are becoming larger and smaller. They are requiring more energy. They are giving us more challenges. And we need to adapt our design to the new and the next generation of data center. It is difficult to define what are the golden rules to design a data center. To be a designer, to be a consultant in a data center business, to be a manufacturer for cooling in a data center business is definitely a challenge. There are no perfect rules to follow to get the deal. However, all of us probably has the experience that we need to fight against these, let's say, 6 challenges. Definitely, we need to reduce the carbon footprint and the energy bill. So this is something that is for our customer to reduce the energy cost, and it is for our planet to reduce the carbon footprint. So the first challenge is definitely the need to reduce the dependence on compressor, to use more free cooling, more economizer solution, regardless which solution this is, but the target is to use less compressor, less large compressor, less compressor usage. The more we are able to do this, the more we are able to improve the energy saving, paying attention to not move the focus on other stuff. There are a lot of economizer solutions are based on the water. That's fine. Water is a good point to reduce, adiabatic system is a good point, a good strategy to reduce the energy consumption, but we need to be aware that even water is something important in our life. So we need definitely to reduce the mechanical cooling, but we need also to preserve the water consumption. Because the data centers are definitely larger and larger. There are a new architecture in data center. There are the clouding that is growing. Co-locator and clouding are growing a lot. In parallel with this, there are an edge computing that is growing a lot as well. And that's not one against the other, but it's a shared and common scenario on that. There is more and more a scenario where all the data, all the software, all the information are stored on the clouding. And then there are multiple levels of small and mid data center that are in the between the customer, the user, and the clouding. So when you are enjoying a movie on Amazon Prime or on Netflix, you are connected to the edge data center that store probably the first 5 minutes of your movie, but the entire movie is stored on the clouding. It is not possible to connect you directly to the clouding because the distance and the bandwidth would be too low to allow to have a clear view of the movie. So we are noting that on one side the data centers are becoming bigger and bigger, and on the other side there are a multiple number of small data centers that are a sort of repeater, a sort of a router of the information. These large data centers are designed for storing data, for managing the software in any condition. So considering also the global warming, and considering that the data centers are located even in difficult areas. So one challenge is definitely to design for the extreme condition. Now, if 10 years ago a nominal condition was 40, 45 sometimes, now even if the ambient temperature is 35 or 40, the data center are designed at 45 or 50 because there are massive data center, and let's think a roof where we have a lot of chiller outside with a lot of recirculation. Even if the ambient temperature is 45, in between the chiller, the real temperature is 50. So it's a challenge to design not only on the real temperature, but what will be the temperature in so crowded area and crowded roof. And on the other side, to design a temperature which allows to have the maximization of the cooling or the economizer. That's a challenge because these two temperatures are one fighting the other. Speed. All of us knows that the clouding and the deployment have a very short time to be deployed. Yesterday I visited a data center that is operative. 1 year ago, I was there and the building was not building yet. In 15 months, they built the building, they designed everything, they installed the chiller, and now they have all the data center already sold to the customer. It's unbelievable how the speed is a key point. And so the only way to speed up the design, the installation, the deployment, is to have a simplification of the installation, to have a package units which are embedded with the key elements. For instance, chiller with the pumps, with the valves, with the water tanks, with the filter, with everything that usually is on the site on board, pre-tested, pre-validated, and shipped. That's a way to speed up. That's a challenge that forces us as a manufacturer to cooperate with you on which is the best way to manage this. Then there are two key points. The energy regulation that are growing, and in any country, any single country are working on energy regulation. That's fine. The problem is that a lot of times these regulations are based on comfort cooling. So we need to consider that we need to comply with the energy regulation designed for a different application. And last but not least, the refrigerants. The Kigali agreement that happened 2 years ago and has been signed by all the countries in the world is going to remove the traditional refrigerant from the scenario. So with different ways and different time limits, all the countries in the world will need to pass through different refrigerants, typically with global warming potential lower than what we have today. It's, if I remember well, there is, India is between 2022 and 2025, but the target is to have a very low global GWP and to reduce the global warming potential by 95% in 2030. So it is a huge challenge, and this means that probably in the next coming years, on a global footprint, a global scenario, all the refrigerants that we know will be replaced. Will be replaced with new blends, with new solutions that for sure will change part of the historical and the traditional scenario we have. So those are what we recognize are the challenges for cooling that all of us should try to overcome. And in order to get it, in order to reduce this and to overcome these challenges, we propose, when we design a large and hyperscale data center, 5 golden rules. You know, again, being a designer, being a consultant, is like to be similar sometimes to be an artist. It's not there is not a fixed rule to deploy a data center, to deploy a new infrastructure. It's something that is based on the experience, is based on the infrastructure, is based on the tradition, is based on the personal habits. That's true. what we should try is to find some general rules that help us in identify which are the big and the most interesting point that can help us in improving the energy consumption, the energy saving. So, to look at the temperature for sure, to check if it is possible to use adiabatic or evaporative solutions. Pay attention on the water consumption, of course. To consider which kind of compressor to use. To evaluate the data center, not at day one only, but in the entire life of the data center. So looking at not at the design at day one, but how the data center can be readapted. And last but not least, to look at how the new refrigerant can be not only a pain in the ass, but also an opportunity to improve the data center efficiency. So those are, again, those are not rules written on the stone. They are not mandatory statements. Those are good practices. Those are rules, the golden rules that, if applied, for sure can reduce the energy consumption. Starting from a simple fact. When we design a large data center, typically there are two solutions. In the data center, in the cooling infrastructure, there are three solutions at the end of the day. Air conditioning unit, PAU, based on refrigerant. PAU based on chilled water connected to a chiller, and air handling unit. On large data center, the more and more the large and the hyperscale data center are based or on chilled water system, so PAU CRA connected to chiller, or to the air economizer, so the air handler. Those are the two technologies that are in the most recent year moving on the large design. This is not said that the DX system, the direct expansion system, are wrong, but on the large and extra large data center, they are less efficient or optimized than these two systems. For sure, looking at these two systems, the first question is what will be the design temperature we should consider. Starting from the latest ASHRAE regulation and the recommendation, looking at what are the recommendations of the REX producer and the manufacturer, and what are the challenges for collocator. If we look at the ASHRAE and the guideline, ideally, it is possible to increase the ambient temperature in the data center much higher than in the past, up to 27 sometimes, knowing that 27-degree discharge in the data center may be a challenge because it is really at the edge. So for sure, the 27 degrees is probably too much. Not all the collocator accept this, not all the customer accept it. However, the message is pretty clear. Let's try to design as more as possible at the high temperature. A good number is 25, 26. 24 is something that's still good, but could be improved. Pay attention that when we design at such high temperature, of course, the thermal inertia in the data center are much lower than in the past. So if we design at 26 and there is any power failure, we need to be aware that all the systems should be restored in less than a couple of minutes, 3 minutes maximum, because otherwise the temperature overcome the 27, overcome the edge. So these reflect also the technology that should be used on the chiller and on the cryo on the air economizer. Now, a must for any cooling machine that operates in data center is a quick restart. No, if a chiller for comfort or a chiller 5 years ago was allowed to have a restart time around 10, 15 minutes, now in data center, and this is still fine for a comfort cooling application. Now in a data center, there is no way to accept any chiller with a restart time longer than a couple of minutes. And I mean with a couple of minutes full load. Because this is the time that your system needs to get temperature. to not overcome the limits. So this decision, for sure, impact a lot in the infrastructure. However, this decision changed completely the landscape and the scenario on the power consumption. Because if you design, when you design a data center at 25, 26 discharge, and this is, let's take for example the chilled water system. This means that the chiller can be designed to operate at water up to 20 degrees Celsius. There are many installations that are working at 20 degrees Celsius discharge on the chiller. And of course, when you move the temperature from the traditional 7, 10, 15 to 20, it means that the chiller is smaller. So this means cheaper. This means that the electrical infrastructure is cheaper, and it is more efficient. The golden rule says that for each degree of increased water temperature, the chiller is able to provide 3% more capacity. It's not perfectly true, but it is a good number. So if we are able to, the more we are able to move the design up to 20, the more we are able to increase the power of the chiller. So decrease the footprint, decrease the electrical infrastructure because the compressors are smaller, and therefore the electrical distribution is less designed for less amperage. The genset could be downsized and so on. And the more the chiller is efficient, the more we can work on this, the more we work on the CapEx and in the OpEx. Then, the other story is, once we design the maximum water temperature, what is the maximum delta T on the water? Because if the data center is designed to work at 25, 26, and the delta T is 14 on the internal side, on the internal air, it is possible to consider to not operate with the usual, let's say, delta T of 5, 6, that is usual for the comfort cooling machine, but to stress this, to operate up to 10, 12 in some cases, of the water delta T. Of course, not all the chiller are of this. It is necessary to have a specialized chiller for that, but the more we increase this, the more we increase the delta T, the less we have in water flow. And less water flow we have, less piping we have, less size of the piping, less power consumption. So definitely on the CapEx improvement, the CapEx investment, the pump are smaller. The electrical infrastructure for the pumps is smaller. The piping is smaller. So the pressure drop is smaller. So everything is definitely more interesting on the CapEx perspective, but smaller pumps means less power consumption. Less water flow means less pressure drop. So again, less power consumption on the water side. And last but not least, if we consider 2030 or 2032, this means that since the free cooling on a chiller is based on the return water, and typically in the free cooling units, the free cooling starts when the ambient temperature is colder than the return water. This means that when you design a 2032 or a 2030, the free cooling can start at 27. So maybe not Mumbai, but Delhi for sure, Bangalore probably, are good location for using the free cooling. So even if 10 years ago, 5 years ago, free cooling on a chiller in India was used seldom or not extremely efficient, with those conditions, it changed completely the scenario. It changed completely the scenario because we are able to increase the inlet water temperature. And it is just a design view, not something magic on the unit. The unit should be designed properly, of course, but it is a design choice based on the recommendation of ASHRAE. We are not reinventing the wheel. We are just applying what the ASHRAE is saying. Of course, knowing that it is necessary to have a unit that is able to do this. Not all the chiller is able to do this, but the mission-critical chiller are able to do this. So definitely that's a very important point which is applicable not only on chilled water system. If we move on and jump on the other side of the design way, so the air economizer, the air handler, the more again we increase the set point, the more we are able to reduce the OPEX. If you design an air economizer at 22 discharge or at 27, there is a relevant difference in terms of power consumption. And the PUE, considering 25, is really low in a worldwide presence. So definitely, the air economizer are based on the same concept, are based on an important point. The air economizer rely on water. So when we consider chilled water system, we consider water consumption out of the equation. When we consider air economizer, it's a fantastic choice for reducing the power consumption. However, we need to consider that the air economizer use water and wastewater. So both of them are the same, two different answers to the same question in two different ways. However, both of them, the more we increase the water, the more are efficient. Point number 2. Let's use water. Some areas has water. Maybe in these days in Mumbai you have too much water sometimes, but the adiabatic of the evaporative solution are part of the story. Not applicable everywhere, certainly not in Saudi Arabia, but in some areas are applicable. And it is another way to reduce the carbon footprint. We leverage on the water evaporation to keep out part of the load using water. So considering that water is part of the equation. But if we consider the air economizer are based on an internal heat exchanger. So let's imagine that this is a package machine. The air enters from the data center on this side. It is discharged on that side. In between here, there is an air-to-air heat exchanger that exchange capacity between the external air. So the air from the data center pass through here. The air from outside enter here and pass through here. So without mixing the air, the internal air and the outdoor air is able to dissipate part of the load. Of course, this is enhanced by some spray here, some nozzle over here that keep this heat exchanger wet. So there is a lot like a shower that keep the data center, the heat exchanger externally wet, not internally, so not on the air that goes to the data center, but to the external air. It keeps wet. This water evaporates. By means of the evaporation, the capacity, the load is dissipated. If this is enough, the air temperature here is at the set point. If this is not enough, then here there is a coil which dissipates the last part of the cooling. Then the water that is not evaporated is collected here and then recirculated. So, but part of the water is wasted, used, part of the water is recirculated. This is based on a solution which, in the event of water unavailability, can work with the water in the water basin, so it means for 90 minutes. Otherwise, you need water tank outside, or you need to have a storage tank or continuous water. That, when the water is operative, the PUE is really low and lower than any other system that is available in the market. So, in winter time, there is just air that enters into the heat exchanger, and that's all. When it is not enough, the heat exchanger is wet, with this adiabatic system. When this is not enough again, because it's too warm, even the compressor covers the capacity, which is the portion which is not covered by the heat exchanger. So these three areas are managed by the control board, and the water consumption really depends on the climatic profile. So it is not possible to say if a solution like this is applicable or not applicable. It depends on the climatic profile, on the humidity level of each region. So, and that's the reason why we have both the solution, because we cannot try to convince you that the air economizer is the best solution or the chiller is the best solution. Both of them are good solutions that depends on the water cost, the water ability, and the ambient climatic profile. For sure, if the water is available and cheap, and if the humidity is not extremely high, this is the best solution to reduce the total cost of ownership. No discussion about that. On the chiller, the same concept could be applied. The only difference is that on the air economizer, typically, the water is essential to get the capacity. On the chiller, the water is usually applied to boost the efficiency. You can use the water also to boost the capacity, but in case of, on the event of water loss, you lose capacity. So our suggestion is to use water only as a booster. So typically, if this is an example of one of our chiller, but that's pretty general. There are typically some high pressure sprays in front of the coil. It is important that the spray should not keep the coil wet, but a sort of media in front of that, because otherwise the coil is corroded. And this media, this filter wet, allow to have a lower temperature, because the media allow to drop down the temperature between the dry bulb to a mid temperature between dry and wet bulb. So this means that if the ambient temperature is, let's say, 45, and the wet bulb is 30, whatever it is, this means that the inlet temperature is around 38, something like that. It means that there is a huge saving of energy for that. And there is therefore more efficiency at high ambient, but more and more, if we design a 2030, this means that we can start the free cooling at 27. If on top of that, we apply the adiabatic system, this means that the 27 is the average temperature between the wet and the dry bulb. That is probably something around 35. So this means that if we design a 2030 water and we apply the adiabatic, the free cooling can start around 34, 33 degree ambient. So in a huge part of the operating envelope of the unit. It's something that again depends on the climatic profile, but it's something that really moves the free cooling operation on the upper part of the climatic diagram. Using water, and therefore again it's possible and necessary to balance the water versus the energy, but it is another tool. Let's look at this as a tool to save energy, and then can help on that. This is something that is applicable more or less everywhere in the world. Of course, it really depends on the location. In Delhi, it is applicable. In other countries, it's applicable. It's interesting to see that the result in Delhi are similar to the benefit we have in Moscow, although the climatic profiles are different. This is because Moscow is pretty cold, and the free cooling, it's a traditionally fantastic place for free cooling. But definitely, with this system, we can have the same result or similar result that we currently have in Moscow, even in Delhi. So that's definitely a change all the traditional approach we have on the free cooling on the adiabatic. So as a suggestion, it would be a good point to analyze if the adiabatic could be or not a part of the equation when we design and we select the chiller. Or an air economizer as well. Point number 3. Which kind of compressor and technology should I select? Now there are multiple compressor available, multiple fans, multiple motor, but one point is the more we use variable speed drive technologies on the pump, on the fan, on the compressor, the more we can improve the saving of the installation. It is something that need to be carefully analyzed with the ambient temperature as well, because even the inverter has some maximum ambient temperature operation, so it's not said that it's worldwide applicable. However, the more we use variable speed drive technologies, the more we are able to reduce the carbon footprint. We have, as many other manufacturers, a double choice, fixed and variable speed. This is not true that the variable speed are the best choice ever. It is something that we need to consider in terms of payback, in terms of approach, but it's important to have and to consider in the equation even this. Variable speed are more efficient because the compressor exactly follow the capacity, and it can be selected on the proper design. If you remember when we talk about the economizer dissipates the large part of the capacity by the heat exchanger, and the compressor only a small portion. This means that the compressors are usually smaller and more working at a lower condition than in any case. So, if the concept is not to have a standard cooling, but a trim cooling, a compressor that trim the capacity, so adjust the capacity, not dissipate the entire capacity. If we do this, and we compare, for instance, a chiller with on-off compressor, the blue line, the red line with a compressor with inverter, at full load, the two units are very similar, because the inverter-driven compressor are a little bit worse, because the inverter has a power consumption. But the more we reduce the load, the more the efficiency increases. So again, it depends on the load and the balance of the load of the data center, and how the data center is designed. If the data center is designed to be a tier 3 or a tier 4, if it's a tier 4, for sure the compressor will work ever at part load. So really, it is another opportunity to reduce the carbon footprint, because in a data center tier 4, the compressor works here in normal cases. So there's a relevant difference in terms of efficiency between an on-off compressor and a variable speed drive. Last but not least, you can downsize the compressor capacity. Downsizing the compressor capacity means that the electrical infrastructure can be downsized. There are two choices on this. Downsizing the electrical infrastructure means to have less capex or to have more space to let. So if we consider a traditional approach or a trim cooling approach, so an approach where the compressor covers only a portion of the capacity with an inverter, there are much more, and assuming the same design in terms of amperage, there are much more amperage for the infrastructure. you have two choices, or to use this if their customer is a co-locator to sell more amperage to the customer, so to have more racks, or to downsize the electrical infrastructure and to have more saving on the capital expense. So it is a balance that you can do. There is an 8% of the capex or a plus 15% more power to sell to the customer. It's a choice of business. Point number 4, the data center, when you design the data center at day one, the data center won't remain constant. You never know what are the evolution of the data center, the load and the approach. So the suggestion is to be prepared for the future. Be prepared for the future means to have dynamic controls, to have solutions which allow the cooling machine to be adapted. Adapted to what? On the set point. So to connect the chiller with the CRA, the PAU with the chiller, or the in-row with the chiller, so the cooling machine internal with the cooling machine externally. This means that at a low load condition, the set point could be optimized. At day one, you don't need the design temperature, you can rise the temperature. Adapt the water flow, so to use as much as possible primary circuits with inverter-driven pump on board the chiller that reduce the water flow to the minimum when it is not necessary to have the full water flow, so at part load condition. There are solutions which allow to have the pump based on pressure transducer, so low load means that the valve is closed, that means the pump is moving at a lower speed. So designing at a large delta T, at the wide delta T, we already reduced the pump power. With inverter, we reduce further the pump power. Last but not least, to link, when we work on CRA, PAU, and economizer, the fan speed to the pressure control into the containment side or under the floor. So the more, again, the less load you have, the less air you need to move, the less fan speed you need, and therefore the less fan power you need. So again, those are 3 examples, working on the temperature, working on the water side, working on the air side, that allow the data center to be dynamically controlled by the internal cooling machine. We are not talking about the BMS or the other solutions here. It's just an internal control. Then the BMS for sure can help a lot on this, but that's an internal procedure that allows to optimize the internal components of the chiller, the CRA, the PAU, the air economizer, to be adapted to the real load that you have today and the next coming years. Last point, refrigerant. On the refrigerant, probably we may have a session only dedicated to that. There are thousands of white papers that are shared and distributed in the last few years. There are a lot of discussion what will be the new refrigerant scenarios, what will be the new choices. What is true is that in this moment, the refrigerant availability, the traditional refrigerant availability is going down. The new refrigerant is raising up, and especially on the large installation. So today, you know, there are 2 traditional, not very old refrigerant, that is the R14A and the 134A. The R22 is out of the equation because it will be banned. It is banned. The 134A, so the refrigerant used on the large chillers, is going to be replaced by 2 blends, but in particular one blend, one refrigerant, is called R1234ZE. The R134ZE is a refrigerant available. It is slightly flammable. it is less, it has a less density. This means that the capacity with this new refrigerant goes down a lot. If there is a very good result in terms of global warming potential, because the GWP for 134A is 1300, the GWP of 1234ZE is almost 1. It should be 4. So on the energy, on the environmental impact, the 1234ZE is definitely a good choice. There is a new blend in the middle that replicated the 134A and has GWP of 700. However, the target for the Kigali agreement, for all the other agreement, is to move to a refrigerant which has GWP lower than 10. So that's the refrigerant typology where we are going to land. We are, and we deployed both the ranges, of course, because it's not possible to have only one, but the 1234ZE is definitely a choice. The efficiency is slightly higher than 134A, that's good. The capacity is 20% less. So taking the same unit, although the unit cannot be exactly the same because this refrigerant is slightly flammable, taking the same unit, the 1234ZE, provide 20% less capacity. This is a lot. This is a huge delta. However, there is a benefit on that. So today, if you are using 134A and you are looking for a solution that works at 2030 and 50, 52, 55 degrees Celsius, this ambient, I mean, this solution is not allowed by 134A because the operating envelope, the gray one is the operating envelope, a normal chiller with 134A. The green one is a typical data center chiller. The blue line is the same with this new refrigerant. So, although you are not forced to use by regulation this refrigerant, I would consider in the equation this refrigerant only if there are installations which require 50, 52 degrees Celsius ambient, and you would like to use water temperature around 2030. That's something that really is part of probably the future of the data center, when and where the water will be more and more high, and the ambient will be more and more high. So probably today it is too early, although the standards are not in some countries asking for that, but it will ask very soon. However, this is another opportunity you may have to reduce and to apply this regulation, this standard we discussed about the water, the delta T, and so on, even on those regions which are really, really hot. That's all. That's all for me. Again, I don't want to give you this as a rules. Again, it's suggestions. Those are suggestions, and in my idea, in my proposal, are just proposal to evaluate when you design, or question you have to consider when you design. Which temperature you have to use? Is the adiabatic or the evaporative system, is the water part of the equation or not? Is the type of compressor something important or not? Again, what are the future of my data center, and how I can adapt the data center to the future, and what are my location, what are my regulation in the refrigerants to get it? Those are questions, in my opinion, more than fact, but those are rules that if we follow and if we apply, definitely can change completely the scenario in the power consumption for cooling, and change the power consumption for cooling, we really change the power consumption of the data center. So that's all. Thank you for your attention today. I hope that this makes sense to you. I will be again in the symposium all the day long, so if you have any question later on, I'm more than happy to talk with you. And again, thank you for your attention, guys. Thank you.
Thank you, Mr. Mauricio. I would request you to please stay back and request Ms. Sangeeta Jangirani to felicitate Mr. Mauricio. All right, ladies and gentlemen, it's time now for a short break of tea and networking out there. And we have got our partner stalls being kept outside, so request you all to please kindly visit the stalls as well. We'll meet you sharply after 15 minutes at 11:45. Thank you.
As I mentioned in the morning, that please Audible, huh? I'm trying to find out. Naveen, alright? Yeah, okay. So this I just switch it off. Good afternoon, everybody. I request all of you to please take your seat. I request everyone who is outside, please come inside. We are starting the second session. I believe all of you must have put your business card at the registration desk, because we are going to pick up the first lucky winner. Those who have not, please do it, because we will keep on picking up. There are 6, 7, 8, 9, whatever. There are so many opportunities going to come. So make sure that your business cards are at each stall as well at the registration desk, so that you have a more visibility and more chances to win. And the prizes are really amazing. Everybody, please take your seat. Everybody, please take your seat.
So friends, welcome back. Who's feeling lucky today? 1, 2, that's it, 3. You're always lucky, you're born lucky, yaar. Yeah?
Whose name is lucky?
Ah, who's lucky? So, Vikas ji, Mr. Vikas Kundra, where are you? He was sitting there somewhere. Yeah, just. Mr. Vikas Kundra ji, कहाँ पे आप? No, I can't see him. You're sitting there somewhere.
कंपनी का नाम बोल दो ना.
Mr. India. Okay, can I have a representative from Zillabeg here? Mr. Vikas Kundra, are you around? Yeah. So Mr. Lucky Vikas Kundra, could I please have you on the stage? Guys, let's give a big round of applause to Mr. Vikas Kundra, please. So he's the partner for Lucky Draw today. And the first lucky person is, sir, Mihir Sangvi, sir. I will read the name. Mihir Sangvi, sir. Sir, settlement karte hain na? And the first lucky person is Miss Aishwarya Ranjan.
Do we have her over here?
Or it's a boogie call.
Oh, she's not there, forget. No, one. Give one.
Let's give a count.
5. Say the name again.
Aishwarya Ranjan from M&R Consultants Corporation. Yeah. Okay, Mr. Aishwarya it is. Wow.
Oh, again, first give.
Sir, Aadhaar card लगेगा, PAN card लगेगा. Come. Most welcome, sir. Guys, let's give a big round of applause to Mr. Aishwarya. And bigger round of applause to Mr. Vikas Kundra from Zillabag. So, sir, over to you. Ensure you drop your cards at all the places. We'll be picking up next bowl from any table partner or anywhere. So ensure your cards are around.
Hello, check this. All right, all the delegates present here, once again welcome you to the session 2 of Symposia 2018. We had a marvelous session in the session 1 wherein the two speakers spoke about various topics. Now for the session 2, I would request Mr. Suresh Balakrishnan, Stools CHSPL India Private Limited to please kindly come on stage. And before that, I would like to say a few words about Mr. Suresh. Co-founder and joint managing director of Stools CHSPL India is a HVAC industry business leader. Over the 2 decades under his leadership, Stools grew to market leadership position in mission critical cooling solutions in India. Stools India has executed several landmark projects for large and high density data centers across India and abroad. Suresh revolutionized the Indian HVAC industry with the introduction of EC fan technology that has since then been adopted widely across the mission critical cooling segment. Before their introduction, HVACs were chosen only based on their acquisition price and not total lifetime operating cost. EC fan technology that significantly lowers total cost in terms of power consumption and maintenance shifted purchase decisions from being based on CAPEX to OPEX. Stools' most recent innovations have expanded this technology to industrial and commercial cooling applications as well. Suresh is currently working on innovations in next generation cooling solutions with Stools' global R&D engineers. Suresh holds a Bachelor of Engineering degree in production from Mumbai University. I would request please give a big round of applause for Mr. Suresh Balakrishnan. And I would request you to please kindly come on the dais for the next topic, future trends in data center cooling, micro DC.
Is it connected now? Am I audible or behind? Yeah, okay. You get the screen? Ah. So good morning, everybody. And I'm here to present the topic on the future trends in the data center industry. Stools is synonymous with cooling for the data center industry, not only in India, but all over the world. But the topic here, if you see, I mean, it is plus infrastructure, because the way data center is evolving in the future, it's not only going to be one equipment supplier who could really pay a specific part unless everything is integrated. You would know a little bit more about this as I take you through the presentation, but the intent of my presentation today would be more specifically to bring across what we see the future for computing and for data center industry over the next medium term, which could be 3 to 5 years from now. A little bit about the company, because marketing is in my DNA. I cannot do a presentation without talking about the company. So Stools today is present in 130 countries, 5,000 employees worldwide, 71 years in business, of which 40 years is in mission critical, that is primarily data center and high-end manufacturing cooling, and clocking $1.5 billion in revenue and still growing. 6 production sites strategically located across the globe. So headquartered out of Germany. Germany and Italian production taking care primarily of the market in Europe and Middle East, Africa. China and India production sites taking care primarily of the Indian and the Asian continent, also Australia. South American and American markets taken care by presence of stools production sites in United States and Brazil. This is a little bit about the Indian facility, which has grown from strength to strength over the last 20 years, and one of the largest manufacturing sites for mission critical cooling in India is very much here in Navi Mumbai, where there is also a lot of R&D, and recently in process of being set up is a global R&D excellence center for design engineering, which would support R&D developments across the globe. Traditional data centers, let's look at where we are today. Traditional data centers, I mean, all of us from the industry have heard about all of this, have been a part associated as users, as OEMs, as service providers, as designers, at some stage. So a typical data center would have primarily these 8 components, and of course much more: cooling, power, detection, fire suppression, typically what we all know about. And this is what traditional data centers look into. Our definitions as we speak in our day in, day out lives today, we say typically up to 50 square meters is a small size data center, which would look like this. Then we would say, okay, up to 500 square meters is a medium data center, a server room, which could house maybe 100 racks, but the components would be the same. And then there is no end to large. Large could be even 100,000 square meters. But let us say, I mean, when we look at not a data center as a building or a whole facility, but as an individual room, then around about 1,000 square meters would be what a traditional large footprint data centers could be defined as. As we know where we are today, what is the tradition as of now, let's understand a little bit about the future. And to understand about the future, we need to be in sync with the market. We need to know where the market is heading. So my next few slides is purely with the interest of aligning what we needing some more backgrounds into what these things mean and how they would affect our lives, how they are already influencing the way we live, the way we conduct our day-to-day routines, whether it's professional life or personal lives. So the trend is these Internet of Things and Industry 4.0 would be the driver forcing all organizations. It's important to understand it is all. That means, frankly, from an organization point of view, I mean, in the future, there would not be companies who are not influenced by these developments. Some statistics just to build up the whole idea of where we are heading. This is the kind of quantum which our chief guest also, Mr. Sinhal, expressed the growth of data and the bubble and the whole. It's not a bubble, it's a reality. The amount of data which is growing and the users which are basically contributing day in and day out. When we look at our phones as we are, I mean, even sitting in this hall or we are moving around, I mean, we are all adding on to data, and the quantum of data is doubling very fast. And this is one projection which the analysts love, because typically projections in business houses are like hockey sticks. They show you an event and then they show you a spike going up, right? That's how presentations are made. But this is one kind of a presentation where really the hockey stick graph is valid, because it beats analysts year after year after year. This is another interesting slide. In fact, just this morning in the earlier presentation, one of the presenter mentioned that the quantum of data traffic is not 8.6, but rather 12.5 or 14 zettabytes. It's unbelievable. I mean, as I said, even before you realize that you have put such a big figure, it's already surpassed. The market is already moving ahead. I mean, not so long ago, at least I remember maybe, I mean, towards the early 2000s, this decade, I mean, we were talking about, it's not dark enough, yeah. You know, आप email भेज रहे हो, कितना है? 10 KB, 50 KB, 100 KB, we were here. This morning, interestingly, when I was looking at this slide, my daughter, she saw this, she could identify KB, but she slipped on MB. She doesn't even know what's an MB, she's 11 years old, because she knows GB. So for the younger generation, I mean, KB and MB is gone. They don't even know what's KB and MB. For them, they start with GB. That's their consumption or their mindset of data and speed, right? So here we are on KB, MB. Then we move to GB. That's where we all are. And the moment GB came in, our lives got a little bit messed up, because then we started holding a hard disk, an external hard disk, and walking around in presentations and meetings. One of my colleagues also has it right now here. So, I mean, those kind of hard disks, external, to take care of the GB. And then we moved to terabytes, the TBs. So then came even external hard disks with more capacity to store data, and something heavier to again roam with the pockets. And so we moved again, coming back, we moved from KB to MB to GB to terabytes. Now, when we talk about the government asking data centers and all of this, we are talking about, anybody? Giga is gone, it's past. Was before tera, it's penta. So then we move to petabytes. And petabytes is the amount of data which is already being computed and already being designed in data centers, right? So we landed up in petabytes. Further comes the next step, and that is, anybody? Today, believe me, I and you will be struggling to figure out all of this ladder. But talk about it to your kids or talk about it to the younger generation maybe in a few months from now. They don't know anything about this. They know everything from here. So then comes exabytes. And after exabytes, zettabytes. Further than this, up to now, maybe they will come up with a new million, billion, trillion. So they'll come up with something else. The intent is, this is how data is growing. This is the volume of data which is generated, which is transmitted, which is being handled. A little bit more about the markets. We have all heard about Industry 4.0. We all know Industry 3.0. What really is the difference between the Industry 3.0 and 4.0? We say this is the future, this is to be there, but what really is the difference? The real difference is integration and connectivity of markets, business, and society. This is what Industry 4.0 is all about. Industry 4.0 for me is not about individually a company having a very good, efficient production. That is not Industry 4.0. Industry 4.0 links the market, businesses, and societies all together. And it could be manufacturing, it could be service sector, it could be anything. So, Industry 4.0 primarily means that you are getting connected completely in your day-to-day businesses. A little bit more. Smart industry. I think most of our homes, we may not even realize, but a lot of this is already a reality. It's not really the future. It's already there. Smart TVs, mobile phones, I mean your home automation systems, all connected on Wi-Fi, wireless Bluetooth speakers, also with internet radio on Wi-Fi. Everything is already there. It's all here. This is a report released very recently by Capgemini. And they say 18% of manufacturers, not service providers, will plan to move to pure service-based business model. What does it mean? This means we've already seen a glimpse of this in our industry before. When mobile companies give you the handsets for free, they don't charge you for the handsets. So the manufacturer is basically producing something which you're not paying for, you're paying for the service. In future, you could have self-drive cars, which you don't pay for, you pay for billing per kilometer. So you could have, in future, a television which we don't bill for. We don't pay. We don't go and buy a Sony or a Samsung or a television from the manufacturer. We buy it from a service provider who has got all Netflix and Amazon Primes and everything, and we pay for a subscription. So this is what it means that 18%, it's a very big amount, of manufacturers will turn the business to service provider based. The estimated value of business here is 600 billion per annum through the service model. And 50% of products will be smart and connected. Now we can imagine, I don't know how many of you heard the AGM speech of the chairman of Reliance, the visionary Mr. Mukesh Ambani, when he said, data is the new oil. What did he mean? This is what it is. The slide before which showed you the number of zeros, the zettabytes. And when you realize that the amount of data which is churning, what's the power behind all of this? It is big data. So like oil is fuel for industry, big data is fuel. It's fuel for all of this to take place. A little bit more about what Cisco says. Cisco says 50 billion devices would be connected as Internet of Things. When we say Internet of Things, it means today we have this projector which is beaming live this presentation. Earlier, the projector was a thing. Today, the projector has got a Wi-Fi connectivity by which it's hooked up to a net, and it beams. Now it's a part of the IoT device. This is what it means when we say 50 billion devices will be connected to the IoT. So everything we do, not only our smartphones, but anything and anything around us, the appliances, which gets connected to the net to be remotely communicated, controlled, is a part of the IoT. Again, you see the hockey stick, and analysts love this. We spoke of Industry 4.0. We spoke of Internet of Things. Little bit to understand what means edge computing. So, when you have the action happening right here, you need sensors and a lot of connected devices to sense and give you inputs. Traditionally today, these inputs are connected to a remote cloud server. If it's an app, or if it's a software, whatever. For example, you want to book an Uber, Ola, you use an app, it's a cloud server. The GPS is what makes it connected all over. So you have a lot of sensors and devices, and you have cloud servers. The edge means when you have localized computing capabilities very close to the action, that's when you are not only using these localized computing services to capture the data, but they are also churning and analyzing the data, and the dependency on this is then reduced. You see, this is a pyramid, so it's kind of a bottleneck today. The moment you find a solution between these two, you have expanded the base. You can then deal with those zettabytes and maybe in future much more larger amount of data. So edge computing is nothing but bringing the capabilities of computing very close to where the action is, and the action is captured by means of sensors and devices to analyze. So we are monitoring, capturing, analyzing, then controlling everything happening here, and only the long-term reporting for management analysis, only the long-term data analytics which could be used future, only the main core, like our accounting record room, only the core important stuff will be kept there. That would be the cloud servers. But don't we now see how the industry has moved? I mean, all of us know, maybe 7 years ago, we were attending conferences talking on cloud computing. And we all said cloud computing is the in thing, and it is. There is no denial. Every app we use today, and 90% of our in-house systems are on some cloud, whether it's an internal cloud or a public cloud. It's there. So that happened. Cloud computing was still so recent, the in thing. But today, if the market has to grow and computing has to reach where it has to go to make Industry 4.0 a reality, then you will need this computing also at the edge. And that's the meaning of edge computing. A little bit more how it works, but primarily to reduce the amount of data transmitted to the cloud, which we just saw, and to reduce the lag time. If it's too far, then by the time the data moves and comes back, there is a lag. And there are a lot of applications where a lag possibly would not be good enough. For example, a robotic trading center for a very big stockbroking house. Every millisecond of a share price movement is important. A lag is not acceptable. It could cost a lot of money. Or we are talking of a biomedical surgery by a very good doctor who's using a robot-assisted surgical arrangement. Any kind of a lag between a signal and his movements could mean death and life. So lag is something, depending on the application, its kind of influence will matter. And so the lag is something which can be reduced when you do local computing at the source. And of course, signal to noise is the disturbance because of the distances. Smart cities, which our government is talking about, which IBM talks about, which everybody talks about, cannot be a reality if you don't have edge computing. So all of this, Internet of Things, Industry 4.0, all of this has to come together to deliver what we call smart cities, in future smart countries, in future smart planet, whatever. So this is how the future should be moving. And so edge computing needs a localized data center. Not long ago, cloud computing was sold on the platform that you don't have to have a local data center, it's very stressful, who's going to manage the local data center for you? You're a company which is into financial business, you run your business, leave the data center to the experts, so hook up all your servers, your softwares on the cloud. This is how the pitch was made for cloud computing to sell, and which is valid. I mean, there is no doubt about it. The fact is that today cloud computing will not help us to get where we want to get. And so edge computing is a must. But with edge computing means localized data center. Does it mean we are gone 10 years back? The same headaches of the past come back? The same questions. How do we achieve localized computing? What about the deployment time? How long will it take? What about the capital investment and the real estate cost? Where do we have the space in existing places? Every office to have a data center at a localized level. It's not possible. Security concerns which were always there in the past, also an issue. So all of this comes back. So always it's a cycle. It's just that in the IT field and in the technology field, the cycle is a little bit too fast. This is what we believe will be a very prominent part of the future. It's micro data centers. And it's, honey, I shrunk the micro data centers is at the end of the day, you bring in everything into a very small footprint. What is a micro data center? It's a standalone rack level system containing all components of a traditional data center. We saw the components of a traditional data center. All of this, when it comes into a rack level computing capability, then we can call this to be a micro data center. And if you look at the line down, the growth in the edge of the network driven by the arrival of Internet of Things will cause proliferation of micro data centers. These are numbers which could surpass. And we are not talking of 10 years from now. This is 2020, which will, pass by a flash, just 2.5 years. Micro data centers at the end of the day have a rack, have power, have cooling, security, monitoring, and service. All of this bundled together. So earlier, the stress of building a complete new localized data center is now reduced by having something which is really a plug and play. Micro data centers are the enablers of the future and will play an extremely big role in the future. The benefits of a micro data center: it's a state-of-art infrastructure because you have the best breed of products which could be shortlisted by the end user or the supplier, the best breed of components, the traditional components, cooling, power, monitoring, security, fire. You could have the best breed of products. The deployment time, suddenly, I mean, I feel that I'm a stockbroker, I have, or I'm a bank, I need a localized data center very quick for my computing, order it out, it comes ready shipped. Like you only have a rack today, you get the whole data center available with you. Real estate, it shrinks a lot, the whole footprint of a data center, and so you save expensive real estate. If you go to BKC, 50 square feet of area, I mean, it would cost crores of rupees. I mean, when you save that kind of money and you could have a guy sitting and working for you on a desk and have a micro data center use a limited amount of space, it's a big amount of impact on the profit line, on the P&L, on the finance of the company. Decision makers will push things in these directions in the future. It can support unexpected business growth, again because of the quick deployment possibilities. And it can be expanded on demand. Typical features or typical standard inclusions in the micro data centers would be the brain, the controller, the EC fan technology, the fire suppression, smoke detection, biometric access, alarms, detection systems, all of this. So all what you would expect in a traditional data center would be included. And then, as you see, if the demand increases, you could have a one rack, you could have a multiple rack, you could have a high density rack, which you will see further as I move on with the slides. But you would have basically a lot of configurations where you move everything and ship it, and your edge computing, which is your need, could be addressed and solved. Typical range of data centers would, I mean, just to give you an example, at the rack level, could start from 3.5 kilowatt, 7 kilowatt, and multiple racks with 20 kilowatts, 40 kilowatts, 60 kilowatts, there could be many of these. This is what the end customers would demand depending on applications, depending on their needs, their business requirements, and this would be ready to move. What next? So micro data centers are there. They will initiate edge computing, and then we have to see what next, because does this replace the hyperscale data centers, the big data centers? No. There is space for everybody. There is space for everything in this network. And it will never replace the large footprints of data centers. Those would go bigger and bigger and bigger. The future trends in data center, cooling. We saw the whole data center itself moved from a secured large space to on-site, on-premises. Now, inside the data center, how do we improve and have more and more and more computing? This is common whether you talk about a micro data center or you talk a hyperscale data center. In both cases, you want to increase the computing power of the data center. The problem today, we could not really call it the problem, but let's say the opportunity today. The opportunity today is to reduce the power consumption of data centers, which is consuming a hell lot of power, and we all know this. I mean, we deal with this daily. The density has a direct influence on the footprint, the floor space, and so real estate price. And then comes the heat, which is generated and then has to be cooled. And in some cases, for some applications, also to deal with the noise with this amount of air and equipment running. This is what all of it is today. And this is where the need comes from. There is a need. This need comes from high performance computing. As a leader in the chip manufacturing, who can always be ahead of the curve and tell you what's coming, Intel already predicts that a large part of future computing would need liquid. Liquid cooling would be a part of future computing. High performance computing is heating up. I mean, the density is going up per rack, and this would not be enough to use air and traditional cooling methods. Who uses high performance computing? Currently, traditionally, there are supercomputers in research centers and government agencies who use supercomputing because of the amount of data they handle is huge. And the kind of simulations which they have to run through needs a lot of computing power. So supercomputing is now currently in a niche user group. But in the future, it's nearly anything and everything we deal with in our day-to-day lives would need supercomputing. Because the demand for the data, the amount of churn which has to take place is more. And you cannot just keep building space and using power. I mean, they have to be used in limitations. And so, these would be the new user groups for nearly everything you could think about. A typical case study to, I mean, you could get into the numbers and have different numbers, but just as a broad-based, when you say a summary of what's going on today, a 10 megawatt, which is quite a big data center, heat load, hyperscale data center with a traditional cooling today would typically have 5.5 megawatt of power consumed. And when you incorporate the chip to atmosphere cooling technology, which I will show you a little bit more in detail, you see the amount of power drops only for the cooling part to enable the data center computing by less than half. And so it's a no-brainer for companies that they will choose this in the future. Today, the demand may be not there, but in the very near future, this is what will come. To give you an overview of how liquid cooling works, primarily what is important to know is you have the server, and then you have water coming right into the server. I remember the times when we were having apprehensions of bringing water into a data center. I mean, the reasons why chill water systems were not preferred over traditional DX systems was the fear of water spilling in a data center and spoiling everything. But technology has improved, and the demand has gone to a level where you need to now get water not in the data center, but directly into the server itself. This is where it's going. And then the heat rejection part could be done in any particular way. The heat rejection part of this load, finally this is the source, this is the core. The core will basically have various ways. That's our job as air conditioning engineers. And so the good news is we will never be out of business, because there is always a need for a good air conditioning HVAC design to give a solution to remove this heat. So there would be multiple solutions here, but this is where the core is. Some of the advantages, very clearly performance. You can use the equipment to the core. You could drive it up to the peak performance. The other part is efficiency. Obviously, I showed you a typical calculation. It's a no-brainer that it's highly efficient when you compare to traditional air cooling today. From density, again, the same, the footprint. We heard about servers in pizza box style maybe 10 years ago. I mean, you can really stack up everything into this floor space and remove the heat. How does it look like? Typically, inside a server, you would have CPUs or GPUs which are taking majority of the power and generating maximum heat. You have voltage regulators, you have the RAM. All of these are what a server internally looks like and generating the heat from here. This is where it is. And then, when you're able to have an engineering solution, and if you're able to connect via liquid cooling solutions and take away this heat directly at the source of generation, then you're bringing in a lot of efficiency, you're saving a lot of space. This is how it looks like with the liquid cool solution on board. Is this very far away? It's not going to affect us, it's not coming. There's a lot of time? No, it's here. Server manufacturers already have servers which are suitable for liquid cooling. It's already there. It's already in use. It's not something which is not going to come in the near future. And how does it work? I mean, basically you have three kinds of modules. It's one which sits inside the server. It's one which basically helps the piping and gets the water into the server, and one which is rejecting heat out. So pretty similar. The air conditioning, if you look at basics, the basics never change. The basics are the same. Today we have a crack unit or a PAHU unit or a chill water unit inside. You have a piping connection and you have a chiller outside. It's pretty the same. It's just that everything is shrunk and everything is now much more efficient. This is how a typical plate-to-plate heat exchanger, which is used in air conditioning or in heat transfer in industrial cooling businesses, it's ultimately the same thing. Of course, it's a different kind of a design. It's more efficient. And this is what is the core which will take out the heat. Quick connections, which have improved over a period of time to make sure that there is no dripping and there is no water which is moving into the servers to secure the equipment. Manifolds, pretty similar again like a piping design which we do on a large scale for a big building. It's absolutely similar to that. You can have them vertical, you could have them horizontal on the rack where water is connected at 2 points on top, and then you have the distribution at the various server levels. So the rack is loaded with different servers, and these servers have connectivity with the pipes in and out. The blue is the water which is going in at a less temperature. The red is water after the heat is picked up. So this is how the manifold system. And this is the heat exchanger. The heat exchanger, depending on capacities, could be small, where you don't have water, but you have like a radiator, a fan, and a coil. So it's air. Then you have water to water, liquid, cooling, and the heat transfer is then through a closed loop liquid system. Typically, a schematic would look like this: heat rejection, piping, connections inside the rack. It's already there. These are no rendered images and drawings on the board. It's already there. Supercomputing is using liquid cooling as a live case. This is a live picture of a real case. It's already there. And it's coming very quick because that's the need. Without this, you won't have edge. Without edge, you won't have Industry 4.0. And if there is no Industry 4.0, I mean, the economy is then waiting to go there. And now comes integration. On one side, we have extremely good computing capabilities now because of the liquid cooling technology, which is helping us to have a lot of heat in one server, in one rack. And you have the micro DC, which is bringing the computing capabilities in a very secured and an efficient manner right where the action is. So when you have brought both these things together, when you integrate these two technologies, you really come up with the future. The really high-end computing is what this is all about. A case for today where we are. If we have a 4 kilowatt rack and we have 16 racks, 64 kilowatt in total. Let us say we are cooling it with a traditional way. So with the traditional cooling systems, considering from a Stools product line, a CRS90 product line with a variable compressor, that means you're using a good technology cooling system. A variable compressor is what today we know helps us to better the power consumption. In such a scenario, we're still talking about consuming 30 kilowatt of power for cooling and a partial PUE. This is not the PUE of the data center. It's a partial PUE because this takes into account only the cooling part of energy consumption, not the total energy consumption for other components. And we are talking of 1.47, which is already very good. When you do the integration, it's very important to see that we are not anymore talking of cold climates, cold countries, where ambients are 10 degrees and ambients are 20 degrees and ambients are 0 degrees. This is for a country like India, where we have 43 degrees ambient temperatures, because there is no cold water anymore. You are having water which is cooling the servers at 60 and 80. It's not 6 and 8. 60 and 80 is the water temperature. which is required to cool. And when you have 60 degrees water to be cooled, a normal atmospheric dry cooler with an ambient of say 40, 41 degrees could be sized and would be good enough to give you the return water. So with this, we are completely doing away with power for cooling. It's taken it to the next step. We are only using power to run maybe the fans in a dry cooler in an efficient way, and rest of it is handled with an efficient system. And then you have, of course, we won't lose completely our businesses, we won't be out of business. We would also have a rack cooling, but of a much less capacity. So what happens? 70% of the load is taken away by liquid, which is to atmosphere. And 30% of the load would be with our air conditioning equipment. And which means now you substantially better the performance. I mean, we all know when a customer calls us and says, I want to better my PUE, and the customer tells us that you need to improve it marginally, I mean, move it from 0.5 to 0.48. Everybody scratches their heads because finally we find no solution to do this. Here you see the big shift in the PUE. It's a huge shift in the PUE, which is showing 1.47 in the earlier slide versus a 1.06. And this is possible when we integrate liquid cooling for high performance computing, and then you have 64 kW of cooling in one rack, which is huge. Imagine the saving of space, power, capex, everything into this. And this is what the future will demand, and this is what we feel that the future will ask for. And this is what industry will be getting ready for making sure Industry 4.0 is a reality very soon. The future, whether it's Hyperloop, self-drive cars, or space missions, which is all underway. We hear about everything, about assisted surgeries. All of this needs big data. Big data at the place where action is. And this means high performance computing where action is. You can really do all of this, which is the future today. Maybe not after 10, 12 years from now, but today it's the future. All of this is already possible with micro data centers with liquid cooling. So this is how we foresee the future. So with this, I think, I mean, the intent was to only give a direction in sense of computing, in sense of infrastructure for computing, and thank you very much for all of your attention.
Thank you so much, sir, for highlighting the future trends in data center cooling. Now I request Amod Dixit, Secretary, ISHRAE, to please kindly felicitate Mr. Suresh. Thank you so much, sir.
So Suresh, I would request you to please stay back. Suresh, please. Rajesh sir, can I have you on the stage, please? So guys, are you still feeling lucky? आवाज नहीं आ रहा है. हाँ? अरे सर, पहला हो गया, आप एक मिस भी कर गए, आपका नाम भी निकला था. मिस कर गए आप. Right? So मोदी साहब के विकास को बुलाएं. विकास जी आ जाइए प्लीज. सर सेटिंग करो ना, मेरा निकालो ना प्लीज. नहीं 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 सर, चलो चलो आओ आओ. अरे क्या बात है यार, ये सेटिंग इसको बोलते हैं. चलो आओ राजेश जी, सुरेश जी निकालिए. अच्छा, फर्स्ट इज फ्रॉम विकास जी, सेकंड वन इज फ्रॉम राजेश. ही वांट्स टू रिमूव 2 राइट. Mr. Raj Kumar from Bridge Data Centers. अरे क्या बात है. Big round of applause guys, come on. सर आधार कार्ड, पैन कार्ड।
वो जा रहे हैं या इधर आ रहे हैं?
हमारा एकदम ट्रांसपेरेंट प्रोसीजर है, बोल भी ट्रांसपेरेंट है, देख के ही निकालते हैं एकदम। Let Vikas ji, I think, Vikas ji ko dene dijiye. So guys, a big round of applause for Mr. Rajkumar. Vikas ji, request you to do the honors, please. Yeah, we can. चलो चलो, राजेश जी ने आज बोला तो चलो यार, आपकी फरमाइश पूरी सर. One more. अरे So the next one is Mihir Sangvi. Sir, thank you so much, sir. No, just kidding. It is Mr. Yusuf Rampurwala from Voltas. Yusuf ji, are you around?
1, 2, 3, gone.
Was it allowed to put the card and go away?
No.
Yusuf Rampurwala.
Yeah.
No, he must be there.
Yusuf ji? नहीं नहीं.
नहीं, फिर गया. नहीं, वो गया. क्या दूसरा बोलता था बोला.
Hey, नया रूल बनाया suddenly. Okay, count of 5. If he's around, I think he's lucky enough, he'll get it. Or else we go for, or let it be? Let him be in peace, okay.
No, proceed, one more.
Sorry, Yusuf ji. Hard luck. नाम जाना पहचाना है. Raghuveer Singh ji from Vertiv, please.
सब backbenchers को ही मिल रहा है.
सब पीछे जा रहा है, setting solid है यार.
It couldn't be more fair than this. Huh? It was a customer and a competitor and everybody.
Perfect. This is all done.
So you should give it.
Yeah, please. चलो so यार यूसुफ जी को भी दे देते हैं यार. Let us make everyone lucky. Yusuf ji, please come on the stage, please.
Sir, photo. आइए यूसुफ जी.
अरे खाली बॉक्स है, सबके सामने नहीं बोले.
छोटा
छोटा वाला आपका ही फैन दिया है. Come on, a big round of applause for Yusuf ji, please. Okay, sir, over to you, please.
All right, many congratulations to all the lucky winners out here, especially Yusuf ji who have come late, but then too he has got it. All right, so we move ahead with the next speaker. It's Mr. Sanjay Jadhav, Vice President, Product Business, Stools, CHSPL, India Private Limited. Sanjay Jadhav is the Vice President, Product Business of Stools, India, which is a HVAC industry business leader. He is a graduate mechanical engineer and having post-graduation in marketing. He has more than 25 years of experience with companies like Voltas, Emerson Network, Power, and Stools. Sanjay Jadhav has executed several landmark projects for large and high-density data centers across India and Middle East. We have the topic, Cold Wall HU for data centers. So I now request Sanjay sir to please kindly come on dais.
I can say good afternoon, everybody. I hope I am audible to everybody. So we all discuss about zettabytes, terabytes, megabytes. Now let's come back to our core business, cooling. We all are surviving because of cooling. So my presentation is going to cover how we are going to cool the upcoming data centers with a minimum efficiency. And the products are going to change. Traditionally, we have done data center with You call it, when I started in 1998, you used to call it precision air conditioner. Then it moved from precision air conditioner to CRAH, CRAH, CRAC, closed room air conditioner. So these all words have been used to cool the data centers. The density of racks also have moved, which Mr. Suresh Balakrishnan has explained you how the density has moved from, I still used to say that time it used to be 1 kilowatt. We used to convince people to move from comfort air conditioning to precision air conditioning, but now it is moved toward micro DC, it moved towards cloud computing, it moves toward data, everything. So with that, let's understand what efficient technologies have to be deployed from our end further. I'll go from here. See, we all, Mr. Sinha also discussed, the people have moved. I remember in 1999, I used to freeze data center at a temperature of 16 degrees Celsius. People never used to allow me to cool data centers at 18 also, at 20 also. So that time, the moment a customer enters in data center, if you don't get air at 20 degrees Celsius, he says my data center is not cooled. So now, with all server manufacturers, the envelopes have moved as per ASHRAE 2013. These are all envelopes A1, A2, A3, A4. Now, server manufacturer has got classification of their servers, which can even still survive till 45 degrees Celsius, which we have already seen these equipments in majority of data centers. But today the norm is saying that let's maintain a rack temperature of 18 to 27 degrees Celsius, which majority of people have deployed data centers a rack inlet temperature of 27 degrees Celsius. And I am saying majority of captive data centers have started maintaining rack temperature, inlet temperature till 27 degrees Celsius. So this ASHRAE is also certified. Again, there is a recommended envelope which says maintain the temperature inlet from 18 to 27 degrees Celsius. Here is the, I hope, global map. So we all have to use now free cooling, adiabatic cooling to ensure that partial PU is improved in the data centers. Fortunately, India falls in a adiabatic range, which you can see use of adiabatic cooling reasonable in all regions from orange to black. This is a global map. At wet bulb temperature less than 24 degrees Celsius, high savings can be reached. The lower the wet bulb temperature, the higher the savings. Stools has deployed one state-of-the-art air handling unit, which will take care of savings and partial PU of 1.0 to 1.1, which my presentation will cover. I feel now the topic is no capex, no opex, total cost of ownership. We have to deploy a system, energy efficient system with low operating cost. Don't look at capex. If you look at capex, low cost system with high operating cost. Now the data centers are going to a big massive spaces, data warehouses are going to come. I have seen you all have seen Flipkart, I have seen Amazon, okay, they used to, while 8 kilowatt, 10 kilowatt, but they will be talking to now 20 kilowatt, 30 kilowatt, maybe 40 kilowatt. So let's see how air conditioning solution is going to get deployed. Stools has acquired one company called Technivel in Spain. They have done a lot of jobs across globe along with air handling unit, considering the usage of free cooling, adiabatic cooling, mechanical cooling with fans. So this is the air handling unit which has been deployed by Stools to take care of data centers. I feel in future they are not going to talk about PAC or POW units. We are going to talk about air handling units, which is in the capacity of 420 kilowatt, which in the end of the presentation I will cover 1 megawatt. So Stools has already deployed projects across globe, a maximum capacity of a unit 1 megawatt. I will cover each and every part of this component, how we are going to achieve. It's called cyber handler. Globally it is called cyber handler. We are going to have a massive air handling, not a small amount of air handling, which will be in styles, panels, and which can be put on the terrace. No need of space in the data center. You can either mount outside the data center and do the cooling. Here are the components. We have a damper, filter, Again, our beloved, I feel from day one, we are using EC fan. EC fan is going to help us in exhaust as well as supply. We have to use plate type heat exchanger, air to air heat exchanger in the air handling unit. Again, filtration, again cooling system, but don't use cooling system for cooling the data center. Use free cooling, use adiabatic cooling, which will cover how it is going to improve the PUE of data center. Here is the data center is on this side, which you again, I feel that ISHRAE is going to a data center only. This supplier is going to data center. So this is data center, adiabatic cooling. You have a mixing chamber available, outdoor air. We all are saying India air is bad. You can, these tools has already got a solution of chemical filtration, which can be built in the filtration, and you can ensure the good air comes. But again, understand the air to air heat exchanger is indirect cooling. It is like a shell and tube condenser. No outside air is going to come in contact with data center air. Data center air, we call it 5 microns. So the filtration level of data center inside air will be maintained, and no contact of outdoor air, which is polluted, toxic gases and everything, will not be coming in contact with the data center. They have divided cooling in 3 modes. One is free cooling, one is wet cooling, one is DX and chill water cooling, depending on customer's choice whether he wants to go with DX or he wants to go with chill water. Change of delta T, changing of internal temperature. So anything below wet bulb 24 degrees Celsius, wet cooling is going to take place in the data center. This all I am going to run one video. So each component will be clarified, how it works, how it operates, and we expect now the change in a data center industry should happen. Instead of using POW, instead of using PAC, let's move towards using air handling units, and let's use natural resources. Let's not burn the energy and run the data center. So here is configurations available, air routing. You can put it on the terrace, you can put it on the wall also outside the data center. You don't have to take any white space which is required in the data center. See, here is the capacity. These capacities are available from 30 kilowatt to 420 kilowatt. So you don't have to say 30 kilowatt unit, 40 kilowatt units. It has got a flexible air inlet and outlet configuration, wall or roof installation. It has got a controller which will take care of free cooling, which will take care of whatever adiabatic cooling, DX or chill water operations, everything will be taken care by that, which I feel our people have says water usage factor. My slide will cover what will be the water consumption when you do adiabatic cooling in the such a huge capacity. For 100 kilowatt, how much water consumption will happen? Again, don't use bad quality of water, use RO plant, use a good quality of water, get the best efficiency out of water also. And ensure that your air to air heat exchanger doesn't get clogged and loses its efficiency when you use air to air heat exchanger. We have a complete selection tool, total tools organization worldwide. Here is the important, we are still talk about air handling unit is with puff. We strongly recommend, human life is more important. Even stools worldwide doesn't use puff for the air handling units. Even we take care of data center with rock wool insulation. When the puff, today we are seeing so many fire incidents. When the puff catches fire, it emits toxic gases. The people doesn't die by burn, they die because of smoke. So use rock wool. I feel as an industry we should make this norm to use rock wool. Puff we use because of light in weight, better thermal conductivity, but puff is not the solution for the air handling units, either to be used in data center or either to be used in the comfort applications. So we, as per Eurovent standards, you don't have to use puff in air handling units. So this is very important, density of rock wool and double skin thickness also. It looks, again I am saying, when you do air handling unit, you have to please give an importance to all these parameters, mechanical strain, casing air leakage, filter bypass leakage, because a small leakage you will lose the PUE, in turn you will lose the money. So you want to save the money, please follow, say thermal bridging, thermal transmission, check. Majority places leakages have to be completely controlled in the air handling units. Filter bypass leakage, casing air leakage. So these all, go to the HU manufacturer who can offer this test and say your product is really foolproof in this line. Here is the game changer, which is air to air heat PHX, which I told you there is no contact between indoor air and outdoor air. you can see hot air and cold air is not in contact with each other. The air-to-air heat exchanger are Eurovent certified. It has got 100% indirect cover E. It has got evaporative cooling also inbuilt in the air-to-air heat exchanger, which my next slide will cover. So you have to deploy this air-to-air heat exchanger, make utilize outside energy, and ensure that data center gets the cooling. Again, the fin spacing depends on your design, what type of air-to-air heat exchanger you are designing. Here is the system which has to be built for adiabatic cooling inside your air-to-air heat exchanger. So where we are saying use the reverse osmosis plant and ensure that the quality of a water, quality of air-to-air heat exchanger has to be perfect. Here is the pumping system which will cover the largest space, high efficient adiabatic system with stainless steel multi-stage. Let's use a component which is non-corrosive, which is with the RO plant and no losing the efficiency for air-to-air heat exchanger. See, here is the calculation which we have done for a 100 kilowatt use in 1 hour, 100% adiabatic cooling, 90 liters per hour is the consumption of water. Another thing is our EBM pass is the one which we use the fans, and you create the array of fans which will be either in supply or exhaust. I am saying for a 420 kilowatt you are going to use 9 plus 9 fans, 9 in supply, 9 in exhaust. Again coming now, each mode will be explained to you in detail. What is dry mode, what is wet mode, what is top-up mode, how when the adiabatics will get on, when the mechanical cooling will get off, when the adiabatics on, mechanical cooling off, when mechanical cooling gets on. This all depends on your psychrometry and which part of India you are putting your system, either in northern part of India, western part of India, southern part of India. Here is the thing when adiabatics off, mechanical cooling off. You can see actually when the outdoor temperature less than minus 10 degrees Celsius, which is very difficult in India, but the modes are available when temperature falls below minus 10 degrees Celsius. So you don't have to run your compressor, you don't have to run your, only the fans are on and fans are cooling the data center. Now here is our condition. Now you see the minus 10 to 19 degrees Celsius. In this range, you are still not running your compressor. You are achieving the cooling by means of outdoor air and with not even adiabatics getting on, and still your supply temperature is maintained 23 degrees Celsius. Only the deployment of these projects have to be customized and have to be worked in accordance to the site location. The importance how to locate the air handling unit, your data center position is very, very important. Now let's come back. Outdoor still getting greater than 19 degrees Celsius. We are still achieving cooling with adiabatics on. You don't have to still get compressor on. With only using a good quality of equipment, good quality of fans, and again you don't have to go for standby. Standby can be built in fans, standby can be built in DX system also. You don't have to go N+1. N+1 can be built in the system itself. Now next is your temperature goes above 30 degrees Celsius. So your adiabatics on, mechanical cooling on. There is the condenser, there is the evaporator. I hope this slide is clear because the confusion will happen where the air is moving, where the air is going. So this is moving towards data center, this data center is coming back, passing through air heat exchanger, and the cooling is happening. So minimal usage of compressor has to be done when we do cool data centers. This is the figure achieved by stools in data centers which has been deployed in Singapore and Hong Kong. These all are realistic figures. It's a partial PV. Now I'm going to run one small video which will give you complete idea how it operates. Escape. I hope it's very clear to you how air handling unit is going to help you to achieve your PUE, and the modes are very clear. So we don't have to buy POW now or PAC. Buy air handling units if you have a larger operations. So let's move ahead. We still have to buy PAC, but so now this is one technology which is going to be available for a future. And now let's talk about big data warehouses, which Mr. Suresh Balakrishnan said zettabytes. So how to handle zettabytes. Here is, you're going to handle zettabytes. This is called cold wall. I don't know what is, I can't measure the height of the unit, maybe close to 6 meters, 7 meters. This is called cold wall technology, which has been deployed, which is operational. When you are going to talk about big warehouses of data, we don't have option. We have to use a cold wall of a 9 meter high, 6 meter high. So we have to make the data space will go up, but as usual, we all are aware, architect doesn't give a space for cooling. He says, okay, और कितना small कर सकते हैं duct, और कितना. So same question is with us also in data center. They are saying, और कितना छोटा कर सकते हैं तुम्हारा machine. So they are saying, okay, go up. How we are going in Mumbai up. Same way we are going up in the data center also, and making big heighted cold walls. It's a part of HU only, but the system is altogether different. It has to be customized. I'm saying it's user driven. It is custom designed and purpose built. These all are greenfield projects which will come in India, which will happen. It's no, I'm not saying it's maybe down the line 6 months. You will see some customer has done job with the cold wall. This is the cold wall, and this is the way data center will look. So maximize utilization of data center space. I can call it white space, and see this is wall. Here is the wall. This is the cold wall. 1, 2, 3, 4. He says, boss, give me air from where you go, but don't come in my space. This space is need for computing, not for your